This is exercise 19 in chapter 6, where we're asked to find the area under the standard normal curve that corresponds to the following z-scores. And in part A, we are given a situation where we want to find the area between a z-score of 0 and 1.55. So 0 in the standard normal curve we know is right in the middle. 1.55 is about halfway between a z-score of 1 and 2. So we're basically looking for this red area in here between a z-score of 0 and 1.55. So what we do whenever we want the area in between is we look up the area below each of the z-scores given. So the area below the higher z-score is 0.9394, and the area below the lower z-score of 0 is 0.5000. And again, we're finding these in our table of standard normal probabilities. Whenever we want the area between, we subtract the bigger area minus the smaller area. So in this case, we get an area in between equal to 0.4394. Now in part B, we want the area to the right of a z-score of 1.55. So we already looked up the area below a z-score of 1.55, and we found that it was equal to 0.9394. Anytime you want the area to the right, using your table of standard normal probabilities, you take 1 minus the area to the left of that z-score. So in response to B, our area above or to the right would be equal to 0.0606. In C, we want the area to the left. Well, we already found the area to the left of 1.55. It is this circled area when we looked up 1.55 in our table, and so therefore the answer to C is 0.9394. And finally, in D, we're looking for the area between a z-score of negative 1.55 and positive 1.55. So negative 1.55 is about here. Positive 1.55 we've already determined is about here. We're looking for this total area in between. So we look up both areas below. We already know the area below a z-score of positive 1.55 is 0.9394. If we look up the area below a z-score of negative 1.95, or 1.55, excuse me, we get 0.0606. So as always, whenever we want the area in between two z-scores, we take the bigger area of 0.9394 minus the smaller area of 0.0606. And so our response to part D of this question would be 0.8788.